Well, hello and welcome, or welcome back, whichever it is. It is time once again to try to fix something. And today on the workbench, we're looking at another PS5 with no power. Those are very rare. But this one actually, it does seem to be no power, I believe. Let's make sure. Nothing on eject, nothing on power. She's really, really dead. So, what's it going to be? We could have a dead power supply. We could have a dead south bridge. We could have a shorted capacitor on the main board. And who knows what else? Let's start getting some covers off, and let's just see which one of those options we have today. All right, the side plate is off, and this is a 1015, by the way. And yeah, somebody's been into it, I do believe. Security tape's removed. It looks like that's been off right there, although it doesn't want to come up right now. Okay, no ripped fan connector. That's a start. I see a lot of screws, lots of screws. No, that one's missing. Yep, somebody's been in here. Let's just hope they didn't put any screws back in the wrong place. All right, I have the fan and the plastic shroud removed, and I'm just looking for 12 volts on this 4-pin connector that goes to the Blu-ray. I don't see anything. I do have AC power into it. So, yeah, dead supply or short 12 volt rail. I don't know. There's something on this Blu-ray drive. I'm not sure how well it's going to show up. There's some corrosion of some kind where the power goes into that Blu-ray drive. Well, I'll have to look at it under the microscope. I can't tell if it's like from possibly from roaches or if it's from liquid damage, but something to keep in mind. Okay, I guess I'll go ahead and now we need to know if that 12 volts is there or not. Okay, let me get a cover off. Let's get down to those 12 volt contacts. All right, just a moment before I dig in any further. I should be able to check it right here now that I think about it. Let me get my meter in position here. I'm in resistance mode, and I've got my leads nulled out. What do we have here? 16 ohm short to ground on the 12 volt rail. I think this is the 5 up here. So yeah, we do have a shorter than 12 volt rail. Well, that pretty much decides it. The board has to come out and bring it inside. All right, well, I have this board out. I'm getting ready to take it inside, and I wanted to show you something. I think we have liquid damage, I believe. You can see where the board was sitting against the frame there. See the corrosion marks? So I'm pretty certain, yeah, that's going to be the cause of our short. I don't know what they spilt in here, but yeah. Let's get it inside, see how bad it is. All right, well, I have made the long trek in from the garage. Let's take a look at this EDM10 board under the microscope. And let's just see what we have. Well, we have a generous amount of corrosion right on the 12 volt bus. We've got corrosion there. And, well, there's some right there also on that chip. And let's see, more right in here. I think that whole bus there. Where's my tweezers? Let's see, yeah, this whole bus right here, all these vias, is going to be 12 volts. You can see where it's been corroding through to the metal cover, the shield over it. There's more there. So these vias are just eating away. Oh, there's more. Yeah. So I'm not sure if just a simple cleanup is going to do it. There's a little bit more in there. Or if one of these capacitors has shorted. It looks like it does seem to be confined to the, well, I take that back. I was going to say it was confined to the 12 volt area at this top corner of the board up here. Here's where the terminals are right there. So it's nearby that, but if I follow this chain of inductors all the way down, I saw some more right down in here. So yeah, that doesn't look too pretty either. And this is, oh, this is the 5-volt circuit. This is the IC that makes the generates the 5 volts, I believe. And there's the output coil for it. Yeah, that's gonna be the 5-volt rail. It connects to F7001. So, well, it is on the same side of the board. The metal shield may have protected it from a lot of this liquid damage. That could be a short there. That's 12 volts going in to the 5-volt circuit right there. So that could be a short. Okay. Okay. Yeah, that capacitor doesn't look too healthy right there, does it? But we don't have a dead short. I'm going to check it again with my meter. I mean, I was getting like, I don't know, 16 ohms or something out there in the garage. Let me get my meter set up here. How low can you go? Let's see. Ooh, 7 ohms. 7 ohms. Well, that sounds like a possible partial short. Let me get set up and let's see if we can clear this short. All right, I think I'm set up. I've got a meter set up. I've got it connected to the 12-volt rail on resistance mode, and we're going to see if we can watch this partial short melt away. I'm going to just take a cotton swab with some alcohol, and let's just start right in this area while watching that meter. That didn't have any effect. Okay, let's see where else. What about, well, I can clean that area there. I don't think that's going to have an effect. Let's find out though. Nope. Maybe a fresh cotton swab. What else do we have? Get where I can see into the scope here. Oh yeah. Oh, this goodness. Still no change though. Nope. A little bit there. I'll leave that alone for now. It's got to be something with a path to ground. What about this mess down here? Yeah, that right there. Let's see what if we hit that with a little bit of alcohol. Anything? Nope. Okay, how about this? Wow, that's a lot of corrosion. Still though, I just splattered it everywhere. And we'll get it. We'll get it cleaned up. A little bit better. Definitely got to clean out from between all these capacitors. we have not affected that short in any way. HDMI encoder, it's got a little bit of, even the HDMI encoder has a little bit of corrosion under that bottom edge. Not much though. But it doesn't get 12 volts, so it wouldn't be the HDMI encoder. Hmm. 7 ohms. Well, you wouldn't think, there's a little bit of corrosion, you wouldn't think it'd be a MOSFET. Because if a MOSFET died, it would have been, close to 0 ohms. But that capacitor up here, what that one? That capacitor looks like it has a crack in it. See that horizontal line? Is that not a crack? Something doesn't look right there. All right, let me just stick a meter right across that. Let me grab another meter. Do I have any other meters? Well, oddly enough, I do. I'll measure right across this capacitor and see what I get. .3 ohms. 0.3 ohms. Right across it. So yeah. Okay. Is there another one, or is that the only one? Make sure I'm looking at this right. Yeah. About 0.3 of an ohm across that capacitor right there. Let's just remove it. Where can I find some solder? Add a little leaded solder to that. Should make it a little easier to take off. I'm going to go to about 430 Celsius. There's a lot of copper in this area. The resistance is dropping on the meter, checking the 12 volt rail. Come on, let go. Got it. And the short did not go away. Okay. I'm going to check this capacitor. Having a hard time getting a hold of this little capacitor. It does not appear to be shorted. So that was not the issue. And my meter went to sleep over there. Wake up. I've heated something up. If I go back here, yeah, half ohm resistance. So we still have a short in this area. Oh yeah. I sure thought there was a crack in that capacitor. But now that I'm checking, I see that same low resistance on every one of these. So there's something. Let's see. Oh, this is 12 volts. This rail would be 12 volts through this coil. What do we have here? Yeah. Very low resistance here. I wonder why I'm seeing several ohms of resistance way back there, though, because I'm reading less than an ohm on this bus right here, like all up down through here. I am reading 0.3 of an ohm. Well, is it varying? That's reading 10 ohms. 10 ohms here. And on this side, though, yeah, I get 1 ohm, or less than an ohm. So I'm gonna have to start separating some stuff. Okay, let me get set up where I can separate something. We gotta divide and conquer a little bit, I believe. Alright, I have overlooked another little area of corrosion up here. Let's just see if that's it. This is, like, here's the 12 volts input right over here. And just to the left, we have this area right here. Did not clean that earlier. It's just not going to be that simple, is it? Something has died. I think what I'm going to do, I think I'm going to lift that fuse right there and isolate that circuit. Assuming that fuse is still good, I haven't tested it. That didn't change it. Still 6 ohms. Put that back. Okay. Okay. What if we lift this coil right here then? Which feeds these buck converters into the APU. Isolate that. Just need to lift one side of it, really. See if I can do that. Alright, that's lifted. And we're still at 5 ohms. Trying to make sure, yeah, I've got that coil is wiggling. She's lifted on one side. We're still 5 ohms. Okay. What about down here in the 5-volt generating circuit? So that should isolate the APU input. You know, all that row of inductors over here. That should take the voltage off all of this. Those DR MOS on the other side. Is it down here? We know we had corrosion in the 5-volt area. Just didn't really look that bad though. What if we lift this 5-volt? This coil here feeds the 12 volts into that 5-volt generator. I don't know if I can lift that easily without breaking it though. That's a thought. Well, I can't really. That's harder to lever up, on one side. It doesn't really have legs to it like the other one does. But I can add some leaded solder to it and probably remove it with hot air. I don't have a handy fuse to pull here. Don't know if I can get to the other side of this coil or not though. Nope. Okay. Let's see if that coil will come off in one piece. Okay, we're down to 4 ohms because I've heated the board up. 3.6. But I've moved that coil. We are still shorted. So I've isolated the 5-volt circuit. I've isolated the APU. I think. I see a coil. I lifted this coil, big one. I see one down here as well, though. Keep that in mind. Well, we're down to like 4 ohms, so in theory I could apply 12 volts to this. and see what gets hot. And I could safely go up to 12 volts. Let's look at the other side of the board. I don't think there's anything on the other side of the board. And I would be wrong. There's corrosion right there. Another 3219 with a fair amount of corrosion on it. I thought the corrosion was contained to the other side. Okay, what happens if I spray this with some alcohol and nothing changes? Okay. What if I remove that IC? Wake my meter back up. Nope. Okay, let me re-tin those pads and I'll put it right back down. So where is it? Oh well, time to probably inject 12 volts in this to see what gets hot. Okay, I think I got my thermal camera set up here. I'm sure my supply is set for 1 volt, half an amp. It's that left channel right there. Just in case there's some short to some rail that's low voltage, I'll run it at 1 volt. Maybe that'll make enough heat for us to see it. Maybe it won't. Let me go ahead and enable this. Half an amp, 0.95 volt, 958 volts. Okay, let me get the thermal camera out. Let's see. Anything getting hot? Let's see. Anything at all? It's not going to be very hot, whatever it is. I'll increase the voltage and current if I need to, which I probably will. Not really see anything on this side of the board. Let's take a glance at the other side of the board. And I think my leads just came loose. Yep. Of course they did. Anything on this side of the board? Nope. Okay. Not that I can see. Just a bunch of reflections. Okay. I'm going to raise the current on up. Raise the voltage up. There's 2 volts. Let me increase the current. 7/10. 800 milliamps. We're approaching 1 watt there. Nothing. Other side of the board. APU. Yep. Okay. Let me turn that off. So we have a short into the APU. All right, so we still have a short, and it seems to be the APU. So turn that off a second. Of course, I lifted part of the APU circuit, but I did not lift all of it. Like if I check, well, right here on that terminal, 6.5 ohms. And I lifted this coil. It's still lifted. That coil feeds the circuit, that feeds these other inductors here, and the DR MOS ICs on the other side of the board. So those are isolated. There's at least 2 rails that go into this thing, rather high power rails. Maybe one of them's GPU, one of them's a CPU. I don't know. But they're both about 1 volt. And we are still, we have a short into this APU, or 1/2 of it. And these 2 coils are still connected. So I need to figure out, on the other side of the board, there'll be a DR MOS IC here and here. One of those must have broken down. I've looked at the capacitors around there. They don't look bad. So I'm going to guess that we have a short on one of those transistors, and I need to figure out which one it is. I'm going to try to do like I did on this big one. I'm going to try to lean this inductor over. If I can get that contact heated up enough. Okay. hard to tell when you have it up enough where it's isolated, because the pad does go under the coil a good ways. Okay, I think I've got that one lifted. Did that change anything? Got a 50-50 shot. Let's see. Nope. Nope. How about the other one? I'm just adding a little leaded solder to this. Hope I have this other one up enough. Yeah, okay. Yeah, they're both up on one side. Now what do we have on that coil? Oh, then we went to 2K ohms. Okay, so it's this bottom one as I look at it here, this coil. So it's going to be the very last DR MOS on the other side of the board that has shorted on us. Which is going to be this one underneath all the blue goo. Unless there's a capacitor under that blue goo that could have shorted. It's possible. But I don't really think so. I think it is the chip itself. Because I don't think the capacitor would give us a short, into the APU. It would give us a short to ground. But this is a short to ground through the APU, which measures about, usually like 4 ohms, 4.5 ohms, something like that. It's low impedance. Now the other side with all these other coils, that's like 0.2 of an ohm to ground if you check there. This one here would be a few ohms. So that's the one that's shorted on us, is the one that normally has a higher resistance. Okay, let me get some of this stuff cleaned off here. And we'll take a look and see if there's a capacitor that looks suspect, but I don't think so. Like I said, I don't think a capacitor is going to give us a short through from the 12 volt side into the APU. It'd give us probably a short to ground. Let's take a look. All right, let's take a look under the microscope at our suspect here. This little DR MOS chip here. I'm in continuity mode. And if we go right across here, the input to the output side, dead short. And we'll do the same thing to this one. Let me get it back in focus. From here to here, nothing. And we've got them isolated. Normally they'd be parallel, but right now, because I've got the coils lifted on the other side, they're not in parallel, and we can isolate the two of them as such. So yeah, let me see if I can find a donor. Should have one here somewhere. And we'll get this changed out. I bet that takes care of our problem if our APU has survived. Well, our DR MOS has been changed out. There she is, our bad one. Which is always a struggle because that part of the board has so much copper, it just really soaks up the heat. It's always a struggle to get one on and back off, but I think I got her down, and I no longer have a short on the 12-volt rail. I've put back several of the, like this inductor that I had lifted, and these two, I put those back down. Replaced that capacitor I pulled off, earlier up in here. I think it was that one of those two. And I think I'd lifted this coil. I put that one back. So I think we're back mostly ready to be tested anyway. So I want to apply 12 volts to the board and see how much current draw we get. That looks good. Yep, up around 300 milliamps and come back down. All right, that looks good. That looks like a board that's ready to try to turn on anyway. So let's get it out there. Well, I take that back. I see one I did not put back down yet. Can you see it? Of course, it'll still, the initialization will still work, but yeah, that right there is not down. Okay. I will put that down, and then we'll go take it out in the garage and test it. Forgot about that little... All right, here we are back out in the garage, and I think we're at the point of testing. I've got it put back together just enough, and I did check. This is the original supply that was in it, and I do have 12 volts there. So it looks like the supply, get that seated good. Looks like the supply is still good. Let's see if she will turn on. There we go. Lights. Fan spin. Maybe some video. Is that asking too much? So, oh, I saw it lock. There we go. All right, we're back to life. Okay. Well, that's encouraging. All right. So, I think I've got most of the water corrosion cleaned up. I do need to take the board back out and replace some of the thermal putty that I removed. Actually, I'm sorry, it's on this side of the board, isn't it? So it's right here. I won't have to take it back out. I thought it was on the other side of the board. So I've got some of that putty. I'm going to add a little bit back in there. I think the putty I've got is pink, but whatever. And I think she's ready to go. Maybe blow it out a little bit. Looks like she's going to start up, though. Yeah. All right. Let me do that. Let me finish it up, and we'll be ready to fully test it. Well, this PS5 is fully reassembled, and if she will still turn on, I think she's completely ready to go. There was a little bit of corrosion on that Blu-ray drive, where the power connector connects. Little alcohol in a cotton swab, and it came right off. So it was very minor, but I cleaned that up. Put a little thermal putty on that area where I had removed it from those transistors. She's ready to go. Well, I hope you thought that was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up, and I will see you in the very next repair. So long for now.